Welcome to the math record. Today I'll be covering Newton's methods to finding zero. So basically this method would help us get a really close approximation to finding a zero, but not really the exact value. So the general method for is going to be actually a recursive formula, and so you're going to have to use the previous term to get the next term. So we say the next term, which is denoted by c plus n, c sub n plus 1 is equal to c sub n plus f of c sub n divided by the derivative of f at c sub n. So basically what this formula is saying is that we add the current term to the y value of the current term divided by the derivative of that current term, and that'll give us the next term. And we keep doing that over and over until we get a close enough approximation for it, until we want to stop, basically. So let's try to understand this using an example. So let's say f of x is equal to x cubed minus 3x squared minus x plus 2. Okay, so first we need to find a zero here. So to start off with a good approximation, let's start off with a like somewhere where we know a zero is going to be. So let's just plug in zero. I usually like to plug in 0 and 1 to see if they work. So 0 minus 0 plus 2 is 2. When we plug in 1, that's 1 minus 3, which is negative 2, minus 1 is negative 3, plus 2 is negative 1. Okay, so what we want to do is that when we choose two y values, in this case I chose 0 and 1, we get a positive value and a negative value. And that's all we need. Because what this tells us is that using the intermediate value theorem, the IVT, the intermediate value theorem, that means any value from x equals 0, since it's 0, to x equals 1, since it's 1, there's a number between these two such that the y values between these between negative 1 and 2. So that means since 0 is between a negative 1 and 2, that means there's a 0 in between 0 x equals 0 to x equals 1. So I usually like to choose something halfway. So let's say x is equal to 1 half, halfway between 0 and 1. You could choose any number. You could say 0.7 or 0.8 um, or say like 2 over 3 or something. It doesn't really matter. I chose at 1 half because I want to. And then basically using Newton's method, first let's find the derivative. So we chose 1 half. So next we're going to have to find the derivative. I'm going to move this a bit over because we're going to actually have to do a little bit of writing. So the derivative of this function is 3x squared minus 6x minus 1. And our first value, c sub 0, or c sub 1, it doesn't really matter, we said was 1 half, because that's one that we chose. So following this, we know that c sub 2 will equal c sub 1 plus f of c sub 1 divided by the derivative of f at c sub 1. Okay, what's c sub 1? Well, actually, c sub 1 here, c sub 0, because we're starting with c sub 0. Sorry about that. So c sub 0 we know is 1 half plus what's f at c sub 0? I mean c at f of 1 half and derivative f at 1 half. So plugging both of these values into our formulas, usually you're going to use a calculator for this because the numbers are going to get really ugly decimals. So basically when you solve this out, this is going to come out as something like 0.76923, etc. But I'm just going to stop there. Okay, now using this number, we could say c sub 2 is equal to c sub 1 plus f of c sub 1 divided by the derivative of f as c sub 1. And that's equal to 0.76923 plus f, the function at 0.76923 divided by the derivative of that function at 0.76923. And when you simplify this value, put them into your calculator, you get 0.746 with 5 decimal places, 0, 0, etc. Okay, now let's plug this into it one more time. So c sub 3 So C sub 2 plus F of C sub 2 and derivative of F at C sub 2. So we're doing all this in our calculator. So 0.746 plus F of 0.746 divided by F of 0.746, the derivative of F, I mean. And then when we finally calculate it this last time, we should get something around 0.7459. So we have a zero that's approximately around, that's a approximately symbol. So it's approximately around 0.7459. Now, if you actually do using a calculator and you solve for the zeros, you're going to find out that the one is like actually 0.74588983, etc. But that's actually a really, really close approximation. We have a 7, we have a 4, we have a 5. The 9 is really close to the 8, 9, right? That's really, really close approximation. And that's basically just Newton's method. Well, thanks for watching, and next video, I'll be covering Euler's method.